Okay, everyone. So in our last lecture, we went ahead and we used a manual way to go ahead and try to extend a frame by adding on to this hello extended frame, a way to import the hello. What we would like to do next is to try to use objects of inheritance to go ahead and do this process the same way. So I'm going to go ahead and create a new file here, and I'm going to save it as, let's see here, this is the GUI2 extended. I'm going to go ahead and call this GUI2 inherit. My spelling's not the best, but it should be okay enough. And to go ahead and get started, I'm going to go ahead and close out of this version of this file, and I'm just going to keep this GUI2 open for us. And what I'm going to do right away is import tkinter. I'm just going to go ahead and import all these items in case I forget one. And then what I'll do is from OLP of GUI2, I'm going to import hello. So again, this is very similar to what we saw earlier where we have these types of imports going on in the previous one. And what we're going to go and do this time is I'm going to call this extender. In the examples, it's called extender as well, rather than extended. And in this version, I'm going to go ahead and actually, you know what? I'll call this inherit. Hello, inherit. And what I will say here is I want to inherit the class of hello. And again, this is the concepts of object-oriented programming with inheritance, where we could say, hey, go ahead and grab all of the functionality of this hello class and import it in. Now, what we can do here is create our init per normal, put it to ourself, and our parent is defaulting to none if we don't provide a root file. And now what I'm going to try to do, instead of in our previous scenario, let me go ahead and open back up that one file that we made where we had it extended. Instead of kind of implementing the frame to be the parent and then making this work in this manner, what we're going to do is call the constructor of our parent class. And we're going to pass the frame that is given to this class into that one. So again, if we provide a root into the hello inherit constructor, it is going to fill in this parent variable, and then it's going to pass it over here. And then this is going to do its normal set of code without us having to need to solve or fix anything. And now if we go ahead and try to remember that we need to take care of the parent on our end as well. And again, our self.parent, which is going to be specific to this frame, is going to be the same parent as the one that we're passing to the other class. We're going to make sure that we say self.parent is equal to parent. And now what we're going to try to do is make sure that we make the widgets of this class. And again, I didn't create this function yet, so what we can do down here now is make a function called makeWidgets. It's going to take in itself, and then just like our previous example here, I'm going to go ahead and try to copy over this button with multiply. Let me put it in like so, and then I'll also copy over that function of multiply as well. Great. Now you can see here that a few things are a bit different, and mostly it seems like there's a bit less of code going on, but again, let's try to make sure that we're not running into any errors just yet. So again, I haven't added anything at the bottom just yet here to run this, and you'll see here that we're not actually getting any of our code to run. So what we would need to do here is we need to define a root frame inside of our inherited py file, and after we provide that root frame, I want to create a hello inherit object. And again, this parent, if I leave it empty, it's going to default to none. And if I try to default it to none, it's actually going to give me feedback here. And let's try to see if this will work for us. Yeah, seems like it's working okay for us. And again, in this scenario where our parent is none, that is going to work. But if we want to try and say, let's add another button into this inherited item here where it exits our program, let's try to make it def of exit self. And then what I will say is, let's do self.parent.destroy, like so. And I'm going to create another button up here that says self text is equal to exit. And the command is going to be equal to exit as well. And I'm going to pack this at the side of, so this was at the top, and these ones were at the right side. Let's look at this one over here. the right and left side, and at the top. Let's try to put this guy at the bottom. Now you'll see here, it looks a little weird because we're not using the rows and columns just yet, but you can see here that even though we're adding all these items in, our tkinter is able to read in data from these guys over here, and it's able to use these. And now if I actually hit exit here, let's see if we can hit OK, it's going to go ahead and destroy my program there. Now inside of the examples, root is provided here. In my scenario, it seems like it worked out okay because I just used the... Oh, I'm using the built-in exit command. Let's go ahead and try one more thing here. There should be a little issue here. There we go. Oops. Custom exit. Self.custom exit. Let's see here. Great. So now if we go ahead and try to run our code normally, it should work for us. And instead of, it seems like my self.parent.destroy isn't working out too well with this custom exit there. So I'm just going to go ahead and add that into right there. And again, because I'm providing this root inside of it, it seems to be working just okay. Let's try to see what happens if I don't provide it. There we go. If I don't provide my root inside of here, my none type gets defaulted and there is no destroy attribute of none type. So immediately you'll see that in inheritance, we don't need to worry about having to add on or pack in the other code from the other widgets into our code here. We can simply just run the parent's constructor that will make that widgets, and then we're going to set our parent in this constructor, and then we are going to run our own widgets. So again, this is essentially what's happening here. You run the parent widgets, and then you run current class widgets, and in technical forms, because they're run after each other, they should be added together and they're kind of combined. So again, in the last piece of information here, you can customize GUI widgets with classes, and what that is saying is essentially you can go ahead and you don't need to recopy over all your code. You don't need to only use the one code. You can essentially, if you have a widget class that you really like and you think it works out pretty well, and you want to just add on to it easily, you can easily create a class again, inherit from the other widget class, and then make sure it runs. And again, make sure if you're inheriting from a specific class that you always try to do the if name is equal to main method, and you make sure that you reference the .make widgets as up here, just to make sure that you don't run into any errors that you might not know about. Awesome, everyone. So again, these few lectures are just about GUIs, getting a bit more into detail with them. Again, the OOP and GUI concepts, the more practice you do with them, the more easier it gets. There's a bit more level of complexity by adding in self and making sure that we reference self sometimes. You've seen in the past few lectures, I sometimes forget to reference self myself. So just make sure you keep practicing with it. In our next one, we're going to look at recursion, and that will be what we do for week 5. Thank you, everyone.